Now when we're simplifying radicals, we are looking for perfect square factors, but we also sometimes will encounter a negative under even roots. So it's important that we remember our rule from our previous lesson. I squared is equal to -1. So if we have the square root of -1, that will clear the radical as the complex number I. Here we have the square root of -4. So we want to think about 4 as a perfect square number, or if it has a factor that is a perfect square, and we can break apart the square root of -4 as the square root of -1, that comes from the negative under the radical, multiplied by the square root of 4. So -1 is going to clear the radical as the complex number I, and 4 is a perfect square, so it will clear the radical as 2. So to write our final answer in the standard form, we need to change the order of the I and the 2. I is multiplied by 2, so the commutative property allows us to change the order without changing the value of the term. So I2 is the same value as 2I. So this is the format we want to leave our final answer. In our next example, we have the square root of -12. So since we have a negative, we are looking for square root of 12 multiplied by square root of -1. So if I choose to write the square root of -1 as the second factor, then I'm already going to have the correct order to write my terms. Now 12 is not a perfect square, so I want to think about factors of 12 that would involve a perfect square. So that would be 4 times 3. That would be a lot better than 2 times 6 or 1 times 12, because 4 is a perfect square. So when I'm breaking apart 12 into factors, I'm really thinking of square root of 4 multiplied by the square root of 3. So the square root of 4 clears the radical as 2. 3 will need to remain under the radical, and then our square root of -1 clears the radical as I. So you could either write your answer as 2 square roots of 3I or 2I square roots of 3. Either way is correct. In our next example, the square root of -99 would mean the square root of 99 multiplied by the square root of -1. So with 99, if you want, you could go back to your factor ladder and start dividing 99 by prime factors. I know that 11 is one of the factors of 99, leaving me 9. And then 9 is divisible by 3, leaving 3. 3 is divisible again by 3, leaving 1. So I know that the factors of 99 would involve square root 11. And then here I have a perfect square. 3 times 3 really is the square root of 9, which we simplify as 3. So 99 is broken apart as square root 9 times square root 11, which simplifies as 3 square roots of 11, and then square root of -1 is I. So we could write 3 square roots of 11I or 3I square roots of 11. Now in example 14, you'll see that this is a little bit unusual to have a negative decimal under the radical. But we know that the factors are involving square root of 0.57 multiplied by the square root of -1. So automatically I know that square root of -1 is going to clear the radical as I. And now what is intended is to use your calculator to get a value for square root of 0.57. So the square root of 0.57 is approximately 0.75. So you're going to have 0.75i for the final answer. Here's another example with a decimal under the radical. So first we're going to break this radical into the product of square root of 0.25 multiplied by the square root of -1. So we know we're going to have a complex number here. And use your calculator to find the square root of 0.25, and that's going to be 0.5. So 0.5i would be our final answer. For the next example, we have the square root of -180. So that would be broken apart as the square root of 180 multiplied by the square root of -1. So with 180, I'm going to divide by prime numbers. I see that it's even, so 180 divided by 2 would leave me 90. 90 ends with a 0, so if I divide by 5, I'm going to get, let's see, 5 goes into 9 once with 4 left over, so 5 goes into 48 times. 18 is even, so if I use 18 divided by 2 gives me 9. 9 divided by 3 leaves 3, and 3 divided by 3 leaves 1. So I can see I have a set of 2's. 2 times 2 would give me square root 4, and 3 times 3 gives me 9, so square root of 9. And then I've got this 5 all by itself, so that's going to be a square root of 5. We know that the square root of 4 is 2, the square root of 9 is 3. So 180 is going to break down into 2 times 3 times square root of 5, and square root of -1 is our complex I. So it looks like clearing the radical, 2 times 3 would be 6, square roots of 5, I. There's our final answer. Next we have a cube root. So slow down a little bit on this one. To have a cube root means we are looking for 3 identical factors now instead of just 2. So we're going to also notice that under the radical we have a positive number. So I'm going to start with 125. Using my factor ladder, I can divide by 5. 5 goes into 12 2 times with 2 left over. 5 goes into 25 5 times. Dividing 25 by a prime, I would have 5. 25 divided by 5 leaves me 5. And 5 divided by 5 leaves 1. Notice that we have 3 identical factors. So I could write that as 5 cubed under a cube root. I have a perfect cube under a cube root, so that tells me that the base of 5 clears the radical and no other factors remain under the radical. So my final answer is 5. In our next example, again, we have an index of 3, so we're looking for cube root. We're looking for 3 identical factors. So this time I have a numerical base and I have variable bases. So I'm starting with 54, and I'm going to divide 54 by prime numbers. It's even, so I'll start with 2. 2 goes into 5 2 times with 1 left over. 2 goes into 14 7 times. 27 is divisible by 3, leaving 9. 9 is also divisible by 3, leaving 3. And of course 3 is divisible by 3, leaving 1. Remember, this is a cube root problem, so I'm looking for 3 identical factors. I could think of this as 3 cubed under a cube root. And my other factor under the cube root is 2. 3 is written as a perfect cube, so that will clear the cube root as 3. So I know that 54 is now going to be rewritten as 3 multiplied by the cube root of 2. I also notice there's 4 written outside of this radical already. So So I have 4 already clearing, multiplied by 3, that will also clear, and it is multiplied by cube root of 2. Next, we're going to work with these variable terms. In order to work with these easily, I'm going to look for any exponent that is at least 3 or larger. Since x squared doesn't have an exponent of 3 or larger, all of the x squared will remain under the cube root. However, 7 is a number that's 3 or larger. So to figure out how much of this base of y clears the radical and how much remains under the radical, I can simply take my exponent of 7 divided by the index of 3 to get 2 remainder 1. This number 2 tells me that the base of y clears the radical with an exponent of 2. However, this remainder is the exponent that belongs with the base of y that must remain under the radical. So I have 1 base of y remaining under that cube root. So all I have to do now is start with writing the terms that have cleared the radical. 4 times 3 is the same as 12. So I'm going to have 12 clearing the radical. So I've accounted for that. Y squared has also cleared the radical. And those are the only terms that have cleared the cube root. So remaining under the cube root, I have 2. I have x squared, and we have y. So make sure your radical sign is covering every term that's remaining under the root. So the final answer is 12y squared times the cube root of 2x squared y. In our next problem, I can see I have a cube root problem again, and it's being multiplied by a negative 3. So make sure you know the difference between when a radical is being multiplied by some term and what number is indicating the index for the radical. So I've got 1080 and I have some variable bases. So I'm going to start with 1080 and set up my factor ladder. Since it ends with 0, I'm going to start by dividing with 5. 5 goes into 10 2 times. 5 goes into 8 1 time with 2 left over, with 3 left over. And 5 goes into 36 times. I have an even number this time, so I'm going to divide by 2. 2 goes into 2 once. 2 will go into 1 0 times. 2 goes into 16 8 times. I have an even number again. I'll use 2. 2 goes into 10 5 times. 2 goes into 8 4 times. Still an even number. I'll use 2 again. 2 goes into 5 twice with 1 left over. 2 goes into 14 7 times. I don't have an even number this time, but I know 27 is divisible by 3, leaving 9. 9 is divisible by 3, leaving 3. Finally, 3 is divided by itself, leaving 1. So notice how I have a set of 3 identical factors, and here's another set of 3 identical factors. So under the cube root, I'm going to have 2 cubed. Under the cube root, I'm going to have 3 cubed. And then under the cube root, I'm going to have 5, which I know I can't break down anymore. So I have negative 3 that already cleared the radical. The cube root of 2 cubed, remember, will clear the radical as 2. The cube root of 3 cubed clears the radical as 3. And then I have cube root of 5. And then I still have to work with x to the 9th, y to the 14th. All right, so working with these terms. 9 is divided by the index. So let's do that right here. 9 divided by 3 is equal to 3. So that tells me that x cubed will completely clear the radical. None of base x remains. With 14 divided by 3, 14 divided by 3 will give me, what, 4, remainder 2. So 4 will clear the radical. That would give me y to the 4th. However, 2 bases of y would remain under the cube root. So that would look like this, cube root of y squared. So let's put it all together. I have negative 3 times 2, which is negative 6 times 3 is negative 18. Then our variables that have cleared the radical would include x cubed. And then remember over here we had y to the 4th. And now we want to see how much is left under the cube root. We've got our coefficient of 5. Then alphabetically, let's see, we did not have any x remaining. But over here we can see that we have cube root of y squared. So I do have a y squared under that cube root. Here's our final answer. Negative 18 x cubed y to the 4th multiplied by the cube root of 5y squared.